Okay, I think we are going to start, right? Okay, everybody, we are now online. Just a quick check the sound. Can you hear me, Victor?
Yes.
Okay. Greetings again. It's a pleasure to be here with awesome audience. I'm Hayrettin Maviş, working as software developer for last 13 years. Before Victor's presentation, I would like to give you a brief introduction to our user group. Then I will introduce Victor and let him show his presentation. And yes, it's now presenting, I guess. JAG Istanbul is one of the biggest software engineering community in Turkey. We organize meetups, hackathons, and code retreat organizations regularly, and we organize our well-known annual conference, Java Day Istanbul, which will be between 24 and 28 May this year, and it will be free, but the seats are limited, so please be hurried to attend to this meeting. And we are constantly discussing how to grow Java ecosystems in Turkey. Therefore, I highly encourage you to join our Slack channel in order to share your experience or ask a question. And if you haven't heard about it, podcast. And if you haven't heard about it, we regularly making podcast, which you can both stream in Spotify and iTunes, and you can find very good topics by amazing speakers regularly in our podcasts, and this should be over 10,000, but anyway, currently we have 6,000 plus members, and we have had 100 plus events. We are actively participating to Java ecosystem, and we are actively participating also to Java community process, shortly JCP. We created a separate work group on this, and we want more people to participate in this adventure. And actually, I believe one day JAG Istanbul will have a seat in JCP executive committee. We are also contributing to Eclipse Foundation projects, especially on Jakarta EE side. And if you want to be active on these processes, please feel free to connect with us. If you want to be participating on meetups or Java Day Istanbul or Tech Day, and want to be a speaker in our podcast, please connect with us. I will share our connection links at the end of the slide. And of course, thanks to our sponsors to let us more active in the Java world. And lastly, a group photo of all good days. Thank you again attending to this meetup. We hope to make face-to-face organizations soon. And now you can find more on our communication channels, and also take a look at our Slack channel. And it's time to see Victor's presentation. Victor is an outstanding speaker, always giving well-crafted presentations. He is a Java champion and independent trainer, and he was ex-lead architect at IBM. And Victor, would you like to continue?
Yeah, I think it's better if you can also give me the ability.
Yes. Okay. Now,
let's see.
Now I will give you.
Can you see the first slide?
Yes.
All right. Yes. Now, this will be, I will jump through a series of slides with you, but as you said, let me continue this. So, yeah, I'm Victor, I'm a Java champion. I'm deeply in love with simple design and refactoring in unit testing, and I was very pleased to see there in your list Global Day of Code Retreat, which is very cool. So you probably are familiar with what software craftsmanship is. This idea of putting back the focus on the technical practices that were there at the foundation of agile. These things were lost. These things were lost. Today, when someone says they are doing agile, what typically means, so if you ask someone if they are agile, what you typically hear is that they measure velocity, they do stand-up comedies and retro blaming. Not really what agile was really about at the beginning. Agile is not about deadlines and moving fast. Agile is about was about, and it should be about also technical practices and focusing on deliberate practicing and the code of ethics and professionalism, and these kind of things really were the basis of agile at the beginning. So let's say to have a way how to promote this, that I founded my own community that has now more than 2,000 developers, 2,600 I think, and I'm engaging this community of mine every single month. I've run myself a bit over 100 events on different topics. If you care to join them, the link is in the chat. Me to organize the panelists only. How do I share it to everyone? To everyone. I'm not sure how to cache it to everyone. But the point is, this is the community. In case you want to join, there are good stuff happening even tomorrow. I will be talking about event storming with someone from Switzerland, and a bit afterwards, 2 weeks after, I'll talk about designing an expressive and performant persisting model with GPA. I mean, how do we create an expressive but yet fast, efficient entity model with Hibernate? I have a website in which I have a blog and a series of my best talks. And what I do for a living, yes, I'm doing trainings for almost 8 years already. 2,000 developers, hundreds and hundreds of teams. Of course, my comfort zone is the Java standard stack, if I can say that. So I'm teaching Spring Hibernate functional programming and Java performance. Just today, earlier, I did a Java performance training, for example. Pragmatic domain-driven design, clean code, unit testing. These are the things that I am most requested for. That's it. I'm also on the social media. Of course, on Twitter is the best way to find me. And in case you want to reach me, you should also probably know that I have a Teachable account, and you can join a webinar if you want, or you can access a recorded webinar from the past. That being said, that was about me. Now let's see this presentation basically. So how do we evolve a clean and pragmatic architecture? And I will try to take the discussion to the things which are not obvious. So I want it to be clean, first of all. I mean, focus on my problem, and pragmatic, which is not over-engineered and not overly designed. Focus on doing the stuff, not dreaming. Let's see. First of all, the most important principle in programming, let me jump to that slide. The most important principle in programming that we should probably always think of is single responsibility principle, which means not to put everything in the same class, not to stick persistence and computations and generating of PDF and everything in a single huge class, but instead break it into smaller pieces, of course, right? Smaller classes focused on doing a single thing. This is something you should always keep in mind, keeping your code focused on solving a single problem at once. Then hand in hand with cohesion, with highly cohesive design, comes coupling, which is the degree in which the components depend to each other, right? This is what we call a spaghetti code, in which every class depends on every other class, and the other one is a more loosely coupled design. Of course, that's what we want from here. And the other thing that the highly coupled design will be harder to change and risky to change. Also harder to unit test and to understand. So loosely coupled is another goal. You do not want to couple yourself with things which are hard to understand or not yours, really. You'll see what I mean in a moment. So, of course, don't ever repeat yourself. That's another principle in programming. Don't repeat yourself. Don't copy paste your own logic everywhere. Now, what I've seen many companies and maybe managers think is that building software is like building a block, floor after floor. But we all know this is far from the reality, right? Building software is much more like caring for a garden, because software is alive. Software changes. The code bases, the code that we write has to adapt, continuously change to the requirements that are always surprising us, aren't they? So code base is a garden, not a construction. That's why you should continuously care and refactor and reshape the code that you have. Code is organic, it needs continuous care. It's actually a movement, the software gardener. There is actual philosophical movement in a software engineer based on this idea. All right. Now, another thing which very often happens is that we can't really predict what will come. We can't really predict the next feature that we will be requested. So the only reasonable attitude regarding this is to keep our code as simple as possible. So our focus as software engineer is to solve the problem today with as simple design as possible. And what I will discuss further is there are ways in which we can go there. One thing to mention, entities, of course, we all know about entities. They are storing your persisting data. But what many people don't realize really, and I've seen it in many projects, is that you are in full control of your entities. You should be in full control of your entities, which means that you are not forced to keep your entities anemic. It means that you can put stuff in your entities that you have, creating such methods that compute different things based on fields, or maybe implementing little state transitions like this. Imagine what happens if you activate a customer. The status changes, the activation date and on the activation user are set. This is all happening at the activate flow. Of course, you should be coming from a status equals to draft, otherwise you are violating the state of this customer entity. So you can implement bits of logic in your customer, and guess what? If you set those fields in this method, you don't really have to have a setter for these three fields after all. You can control the transitions of the state using such little methods built in your entities. And this works perfectly with Hibernate because you don't really have to have setters for your fields. Hibernate will use reflection and reads from your field anyway. So what I want to say here is that you should always be looking to add some bits of highly reusable logic in your entities, like these little can place orders, which check some things regarding the state of this entity and returns true or false. These kind of methods are very helpful and can simplify the core of your logic by pushing the logic into the little entities that you are working with. Now, value objects are something that also appear in our entity model, right? So entity model is what stores our persistent data. Now, value objects, as opposed to entities, don't have an persistent identifier. That's what makes them unique. Those value objects don't have an ID, don't have a primary key, basically. As you can see, currency and big decimal are just two fields in an object. So this is a very focused little object with several bits of data that move from here to there. They are typically best if made immutable with Lombok or any other ways, but they are typically best if made immutable and kept small. Also very smart if you put some validation in them so that you are sure that these are always correct. So there is no way to work around these. If there are no setters and the constructor validates the data, then you have, by definition, the guarantee that all the instances are valid, right? So this is something good in a large project, to have this confidence that the state is correct. Now, as I mentioned, the difference between a value object and an entity is that only an entity has an ID, a persistent primary key, whereas a value object like this doesn't make sense to have an ID. And to be honest, these are not persisted in the database. These are not persisted in their separate table, no. But wherever you have a money in any entity, anywhere, perhaps the order, for example, whoever references the money will have these two columns in their table. So in the orders table, these two will be present. So what I mean here is that value objects are a way to model the data in the Java world, but in the relational database or your data set, whatever that would be, it can be persisted in the same tables. They must not be, they don't need to be persisted in their own tables. Right. Now comes the fun part, because okay, we have this entity model, and most of us do, but then we have this thing happening every now and then. We have to call outside. You see, we have to call a system outside of our application. Imagine you have to call this other API that you are given. You have some external API of some other project, perhaps, of some other microservice, some other foreign, completely different foreign API. Now, the adapter is a pattern which is supposed to shield you from talking directly to this external API, right? So the purpose of this pattern is to convert that ugly API into something that you want to use, into a better interface that you will use in the remaining of your code. So if this is your domain logic, if this is where you implement your business rules, then it's a place where you want to keep a peaceful and very, very zen, like full of harmony place, right? This is your Zen garden. This is your place in which you want to implement your business rules. But then something weird happened. From that Zen garden, you have to call some external API. If you call that external API, you might have an unpleasant surprise. You might run into some very ugly API like this is. Imagine sending a data as a string. Who does that? I mean, really, data as a string, in what format? Even the very fact of calling this method is very annoying. Get you to format dates into some specific format. It's very, very, very ugly. So you do not want to talk to this API directly from where you implement your business rules, but instead you want to put an adapter in front of that external API. This adapter will wrap around the ugly signature and will expose to you a better API, taking a date, or even better, a local date as a parameter. Of course, internally, this adapter, this new component that we've identified, has to convert from the local date to the date string that will send further, right? By the way, folks, I forgot to mention, any questions you have, just ask them in the chat, and I'll do my best to answer them when you ask them, or if not, at the end. So just ask everything that crosses your mind, okay? I mean, it's more important for me to answer your questions than to really finish all this discussion, really. Right, should I enter that Slack? I'm not sure right now, but yeah, let's see. So the first thing we do is we convert the dates to the thing that I need to send out to that external API. We call the external API, and then we probably have to convert the thing which we got back from that external API into something that we want to send to the remaining of our code. And this is very interesting. The conversion of data happens in the adapter. Sometimes we also want to catch any exceptions occurring from outside and wrap them in our own exception, right? Like rethrow them as my own exception. Right, so this is basically the purpose of an adapter, to transform the data, maybe validate and do error conversion. Good. Now, this is all good and fine, and is a very interesting thing whenever you want to talk to some legacy code base or some very old API that you don't want to know about. You can defend, you can isolate your domain logic by means of this adapter. Okay. So this also allows a place where you can defend from any corruption that's actually, I'm not inventing this term. Anti-corruption layer is a pattern from the domain-driven design world. It really means that it gives you the opportunity to defend against anything coming from outside. Now, the things that can harm you are changes, right? Imagine a superficial change, like having to pass this extra argument to this method. If the external API changes in this way, then you are forced to change wherever you call that external API. Now, if you have an adapter, sometimes, not very often, but sometimes you can only change the adapter and leave the remaining of the code unchanged, untouched, which is very good. So it's like a first line of defense against changes. Sometimes the changes can be dramatic, like for example, instead of sending a REST call, some other system might ask you to send them a message over a queue. You might actually, and I've done that in some occasions, you can actually accommodate this change inside the adapter. Send the message on a queue and then block on by waiting on another queue. Not the smartest idea to block to this reason. Yes. Was it? I heard something. If there was a question, please ask again. The point is, if there are changes in the external API that you are consuming, you can adapt to these changes in the adapter. But that's not the best thing that adapter can do for you. No. The best thing and the most, let's say, subtle thing is when you are retrieving data from the outside world. Now, imagine you are calling some external system to get the user from them. And in their perception, this is the user, right? This is the data structure. This is their understanding of a chicken. If you ask them, this is what they will send you on the wire. This is in their JSON. But this is not what you want to propagate inside your system. This is not what you think a chicken is. So you see, the data structure that they send you can have 80 fields, for example, right? 80 attributes in the JSON, but you don't need 80 attributes. You only need 10 or 5. So then you want to convert the data structures they send you into a better representation, into a representation which is appropriate for the application that you are currently building. So what I mean here is that the conversion from this to this should happen in, this is chicken with cream and mushrooms, my favorite food. So the conversion between these two should happen in the adapter, the data conversion. And this is very powerful. At first, you don't think, I mean, you might not think this is something big, but it allows you to shield your application from data structures that are basically controlled by a different team or a different application or coming from a different world, right? And if you do that, you are basically addressing the problem of bounded context. You are implementing what we call a context map, a mapping between two universes in my adapter. Right? So there might be a user that I'm retrieving over the network from the LDAP service, for example, but I could also have my own user persisted in my database. Somewhere the conversion should happen, and that's the adapter. This is interesting, but you see, something funny will happen sometimes. The domain service, where you implement your business logic, might want to call out an external service at some point. If you call an external service, if you call a class, as I mentioned, right, I should not call that API directly. By the way, data transfer object, representations of the JSON or XML objects that move over the network from that external service. We just said that we don't want to call directly the external service, but instead I want to isolate the domain by means of an adapter. And this is my adapter. Now, I've also moved the adapter into another module. I called it the infrastructure module. Now, the trick is that if from the domain you have to rely and to call the adapter, then in order to see the adapter, you have to depend on the adapter. So if these were two Maven artifacts, if the domain POM was here and infrastructure POM was here, then in order for your domain to see your infrastructure, you need to depend from your domain towards your infrastructure. I mean, there is no other way you can see this class, but to include infrastructure as a dependency of your domain. But this is dangerous. In larger applications, this is dangerous. Why? Because by mistake, by not being attentive, you might actually slip the external data structure into your domain, and you do not want that. You don't want the data structures from outside to be even able to enter your domain. So what you do, you will take this adapter from here, extract an interface from that adapter, let's call it iAdapter, and make the adapter implement the interface. Pay attention what I did. I put the interface in my domain, and I've implemented the interface from my holy domain into an adapter which sits in a different module. Now, why? Why did I do that? Because if this is the case, then the dependency that I had to that infrastructure now can be reversed. If you look here, what happens? I don't need, my domain service doesn't ever need anymore to know of the adapter implementation. It only needs to know about the interface. Wow, that's interesting. So what happens? In words, whenever you need to call some external service from your domain, from your core logic, you should first express your desire, your need into a domain interface. But when I say domain interface, I mean this interface, because it's part of the domain, can only talk in terms of your entities, can only take and return entities and value objects from your own entity model. So this is very powerful, because by this way, you have the guarantee that my domain service doesn't know anything about this adapter. Then from the adapter, you come and you implement your stuff. You implement that interface by, of course, converting and changing and talking in terms of DTO to that external service. So this is basically it, right? At runtime, the dependency at runtime, the domain service will be able to call the adapter, because if you inject an interface with Spring or CDI or EGB like that, then the implementation of this interface doesn't. I mean, if there is a single implementation of this interface, then Spring or any dependency injection framework will know how to wire the things up and to inject you the implementation in the domain service that you had. So this is very, very powerful, because your domain service at compilation time can know nothing about any data structure, anything which is not yours, which is not part of your domain. Right? So basically, this is called dependency inversion principle. Whenever a higher level module, in our case, my domain, doesn't know about the lower level module, the infrastructure module, but only the infrastructure module depends on the higher level module. It's called dependency inversion because the code dependency goes from infrastructure to domain, but the runtime call goes from the domain back into the infrastructure. Okay, so they are inverted, right? If you do that, there is no possible way that anything from the lower level module is visible in the high level. Just imagine there is a class C over here. If you from the domain don't have this module among your dependencies, there is no way you can ever see that class, which is very, very, very good stuff, right? You can use this technique whenever you want to start an integration using some data structures that are not yours, that you don't want to know about in your domain. So I am talking about drawing a line between what's yours and what is not yours. But the structure, the format of a message that you send as JSON, or the fields of a GMS message, or the attributes or the columns in a file have nothing to do with your particular domain module, with your domain model. It's just some external representation. So very good stuff to keep in mind, and this would actually allow you to build a domain which is focused on just your world, right? Which doesn't have to work with different representations of the same concepts, which is very, very powerful in practice. Right. Now, let me just draw a bit of order here. Okay, yes. Right, so by doing that, you can make sure that your domain remains independent of anything from outside. Right, now, we need next to talk about the facade, but I want also to give you some bigger picture over here. This is what we are heading towards. This is the clean architecture, also named the universal, hexagonal, ports and adapters. Now, this baby has 5 names. The thing that I will show you right now, it has 5 names. It's called universal, onion, hexagonal, ports and adapters, or clean architecture. Every smart guy out there reinvented this every 5 years. So I think the first name was ever ports and adapters. I think that was the first name. Uncle Bob, of course, called it clean architecture. It all means a single thing. Let me show you all in the single picture here. This is the clean architecture. We have a domain in the middle, which is completely independent of everything which is outside. We have the adapters that you've put in an infrastructure which sits outside, I mean, which is separated from your domain, right? Just focus on this part. Separated by what means? Because we just mentioned that the adapter will implement the interface that we've identified, right? So we understood this part. Right? Inside your domain, there are entities and value objects which keep your persistent data, or your domain, your data basically. Down here are the repositories, but today with a Spring Data GPA or Spring Data Mongo, or even entity manager itself, even GPA itself allows you to, I mean, the repositories implementations that we write on top of using GPA are not that ugly, really. Are talking only in terms of our entities, right? We are only see names of the fields in our entities and stuff which is part of our domain model, basically. So in this perspective, although classically you should have separated repository implementations also, today with Spring Data doesn't really matter that much if you keep the implementations for those repositories in your domain. Doesn't really matter that much today. However, if you are still working with a GDBC, plain GDBC like resolve set and prepare statement, God forbid, and if you have to handle SQL exception and release connection, God forbid, if this is the case, then probably you want to decouple that garbage out of your domain because it's so ugly. But while you are using a GPA and while you are selecting only in terms of fields of your entity model, then I don't think that should be decoupled anymore today in Java. Good. So that being said, repositories doesn't really exist as a separate module. This one does pay off because you talk to external APIs. But then we will focus in the following on this part, on the facade. Now, you see, the domain will call the adapter, the domain will call the repositories, but in the other part here, we have to handle requests coming from our users, right? And whenever requests come from our user interface, something funny will happen. There will be data transfer objects, JSONs typically, which are sent and received by our, I don't know, React, Angular, Vue application, whatever is there in the front end. So there are JSON on the wire. Those JSONs are mapped to these data transfer objects by Jackson, whatever you are using. Now, from this moment on, we realize that we have two divergent data structures, these and these. What do I mean here? There will be a user DTO somewhere that will carry the data to and from frontend. But there will also be a user entity in my entity model, probably. So somewhere we have to do the mapping, right? Let's start with the facade, and you will get the point. Now, the facade, let me just check that. Yes. The facade is right there. Actually, you know, let me first give you the context of the typical application. So I've been to hundreds and hundreds of teams, and I've seen all sorts of architecture, but what I see everywhere today is that there is a layer of controllers, which is typically very thin, composed of a single layer of a single class, basically, or actually a cluster per groups of URLs, if you want to say that. So there is a thin layer of controllers. Right? Underneath that, there is always a service layer, which implements all the applications that I see today have a service class. Right. Now, below that, there is a repository all the time. Good. This is somewhat standard, right? Do have to add one thing here. I've seen services of not 1,000 lines, no, my friend, 10,000 lines. I've seen services of 35,000 lines of code. So pay attention with these services. They tend to grow very, very large, especially if these services, in case your order entity has 80 fields, yes, 80 fields and columns in the table, right? Then please do yourself a good and never create order service. Because if the order entity has 80 fields, you can imagine how big the order service will grow, right? So for those huge entities, never create a service with the same name as the entity, because you can put everything in order service. What I want to say to you in the contrast is I want you to create not order service, but instead maybe place order service. You can't possibly put that many things in place order service, can you? Right. So try to aim for more focused names, especially for the services which are referred to big entities. Closing the parentheses and moving on. So all the applications today, controller service repository, controller service repository. Good. Now I've just mentioned that sometimes when you call some external API, especially if that other application that you are calling is very large, LDAP, Salesforce, I don't know, SAP, very big, especially then, it's very important to defend your application with a layer of adapters, not to allow the data structures from the outside to penetrate your domain. So this is what I mentioned previously with adapter in infrastructure, right? And this is basically the infrastructure layer, which many applications don't have. Some applications don't really need because they don't talk to others or they talk very little. But if you integrate with a lot of applications, the things can get very messy. And I've seen several weeks ago an application that had to deal with. I actually asked the people. I saw a DTO in the middle of their service, and I asked, "What the heck is that?" And they told me, "Well, this is the data structure from that other microservice that we are calling, but we don't really know what this field is representing." Just imagine, they were using a data structure that they didn't really understood what it represented in their core logic. This is so evil. Your core logic should only be implemented on top of your own entity, on top of things that you are crystal clear about, that you are perfectly aware what they represent. Good. Now we are facing here what is typically known as the layered architecture. This is the layered architecture. Layers which depend on one another, with the condition that layers only call down. The layered architecture doesn't impede you to reverse the dependencies like we've done. Remember, adapter implementing an interface from here. This is still okay, right? But you are never supposed to call back from a repository back into the service, for example. This is a violation of the layered architecture. Right. So we do have calls that only go down, right? This is fun. Now, in the service layer, we typically should only be working with entities and value objects, of course. Then in our controllers, we typically want to use some data transfer objects which are dedicated, crafted just for the benefit of our user interface. Right? Typically, those structures that we send and receive are very close to how the screen looks. To give you an example, there will be probably a JSON which will represent this row, right? Which customer name, last order date, region. So there will be a JSON with just these informations over here. This JSON has to be specific, basically, to our user interface, right? Since I mentioned this, there is one thing I need to add here. If you ever have to select a random grouping of things from your database, like for example here, I'm taking the name from the customer entity, the date from the order, region, and responsible. I'm accessing basically 4 tables with this. Now, it is an anti-pattern to select customer entity, order entities, region entities, and user entities. When you gather this information, it's an anti-pattern, it's inefficient. What I want you to do is to directly select these things. If you are using Hibernate, as you probably are, there is a syntax: select new, X, Y, Z, my DTO, which is called selecting colors, or not colors, it's called actually projection queries. You can select new with GPQL, which is GPQL, and you can directly fill an instance of this class. Directly, selecting DTOs from queries, you can do that. It's a very pragmatic style to bypass, basically. What I will do is I will go directly to my repository to select my DTO. So yes, I am selecting a data transfer object from a query running a database. This is extremely pragmatic. Some people will be, what are you doing? You are going from a facade directly from the beginning directly to the repository. Really? Let me show you this. Maybe let me see, where did I have that? It's into the design pattern. Just several seconds, please. Design patterns. I already have it open. So somewhere in here I have a facade here. I will explain what the facade is in a moment. But there somewhere there will be this thing, okay? And here it is. In the I don't have a find, I don't have a search. But if I had to search, don't I have here any repo? Let me just check. No, I don't. Not here, but where did I have it? In the DDD application, I think. Let's see. Am I lucky? No, I'm not. I don't have an. Yeah, there we go. So this is the syntax. Select new result, which customer search result is actually a class which is thrown out as a JSON. Nothing more. Nothing more. Look at it how it looks, right? And if you're hipster enough, you can put data here, and you just delete everything, or even better, you can put value, right? And delete everything like this. But what I mean here is that these objects, which are then sent over JSON, can be directly selected from a query in the database. Right? This is how it could look. And then the search will be directly called from the beginning of the flow. So this is what I meant here. You can directly select stuff from your database, which is a very good idea. But coming back to my discussion here, this is a standard style of writing an architecture for an application. But then, at some point, you realize that that there are some concerns, such, for example, the mapping, the transformation between the JSON object and your entities has to happen somewhere, right? Most teams that I work with, they do the transformation in the first layer that they ever call. So if the controller calls this first service has the responsibility to convert from the DTOs to entities, right? But then validation is also a common concern, and this is typically implemented somewhere at the beginning. If you are not using annotation, probably also in the first service. Transactions are also a common theme. You do have to have atomic flows. So you might be tempted, and it's quite a typical start in any project, to put a very simple transactional here, or transaction attribute, right? And to transact all the flows from here below. Okay, so these three concerns will typically be the responsibility of the first layer of services. I mean, most teams will start transactions from the first place and validate at the beginning and convert data at the beginning. And there we are. After several months, maybe a year of development, you realize that this first layer of services is somewhat special because it also does these concerns, right? And at that moment, you realize, wait a second, let's give these babies, these things a name. And this is how the facade is born, basically. In a very pragmatic approach, after several months of development, you realize that, okay, so we have these common concerns. Let's extract a layer to address them. And this is what the domain-driven world talks about an application service. They call it an application service. Now, but really, in the old patterns, this is the facade, basically, because it's also typically this first service will typically orchestrate and delegate the work to other deeper domain services. So what I mean here is that the facade is like an orchestrator, right? Coordinating the work, the little steps which are implemented by other domain services. All right, and now the real pragmatic part of the presentation kicks in. But as you see, we have a decision to take. We have some options. Now, always in any application, there is logic being poured upon us. Business asks us to implement different business rules and requirements, and we have a hard time finding where to implement those. Now, the default for putting the logic is, of course, in the services. Right? This is the default, to have very anemic entities and put all the logic in the service. But you will challenge this after you read this blue book. You will challenge this assumption, and you will start pushing harder to put more logic into the entities that you are manipulating in value objects, and push logic next to the data, whatever, I mean, OOP style, right? However, no matter how hard you push, you will never get more than 5 or 10% of logic into those entities. Maybe 15 if you really push hard, but the majority of the logic will still remain in the services, right? The majority of the code, at least, right? But then suddenly we have another option here. We can also put stuff in the facade. How do we choose? Right? And there's actually a very difficult debate in the domain-driven applications also. Sometimes it's very hard to tell if you should put some logic in the application service or in the domain service. But the point is that I will show you now in the following a very pragmatic style of coding. My preference, pay attention, I will always start implementing every use case in a facade. Everything. Now, if the use case is very trivial, here, skip. If the use case is very trivial, like for example, find by ID or search or something stupid, something like most of our use cases are, right? I mean, find by ID, what the big complexity is there? Or this baby, find by ID. What I need to do here is just some conversion probably, right? Let's try to extract this in a, I don't know, like map. I should map my entity to my DTO, right? And this is one thing you can do this. You can actually put all this in a separate method, or even maybe put all this in the DTO itself. You can actually pass this entity to the constructor of the customer DTO itself. So what I did here, because the customer DTO knows now to construct itself based on the customer which is given, pulling data out of the entity. This is the entity, just to be clear, entity. So you can, and if you do this refactor, what you are left with is just a one-liner. I wouldn't create anything more than a single method for a finder like this. It's just too stupid, right? So find by ID remains a very simple method in the facade and nothing more than that. Good. However, every now and then there are more complex use cases. If you encounter a complex use case, whenever there is heavy logic, you should probably extract this into a domain service, So any complex logic, any complex use case deserves a domain service. Imagine the flow to place an order in an e-shop. Oh my God. Definitely there should be a domain service for that. Probably maybe not a single service, but 5 or 7 domain services delegating to one another. So because it's so complex to place an order. So any, like, imagine this one, cancel insurance service. I mean, whoa, wait a second. There's a lot of stuff to do here. Right? All right, so this is something very interesting. Every time something grows big, you should extract it out of the facade. But if you do that, you have a very interesting benefit. You see, the facades are forced to work with DTOs, stuff that come from outside world as a JSON. Okay, but then whenever you extract some stuff out of here, let me try to do that, like BizLogic, and yeah, I will move this to move to customer service. Right? If this is the case, then you realize that I'm only passing customer, not the customer DTO. So when I will extract this to a separate class, that other class will know nothing about my DTOs, which is an architectural goal. I do not want to leave my DTOs to enter my domain. What do I mean here? I mean that I will draw a line over here, separating domain services from facades. Let me try to give you a more exact example. No, this is too boring. Let's try customer facade. No, I don't have an example right here already available. But if the facade delegates to the domain service, don't I have it? Just a second. Supplier? No, not yet. I will build this. But the point is, when the facade delegates to a, for example, order service, right? If I delegate to the order service will know only about my entities. Why? Because I will draw a line over here and I will put all of this into a separate module. Remember the big diagram? There you are. The facade will depend on this. So if the facade depends on the domain knows nothing about the DTOs. Just think of it for a second. The facades are next to the DTOs and are calling into the domain service. Let me try to actually build this order service. You see, order service is part of the domain. I came here from the order facade, which is part of the application. I'll explain in a second. But the point is that in my domain, if I try to access order DTO from my domain, let's try order DTO. It's not the one that it's from Spring Framework data. It's another thing. It's not my order DTO. It's not the order DTO from facade DTO. Why don't I see it? Because I'm in the domain module, and the domain module knows nothing about the facades. The domain module depends only on core libraries. On the other hand, the application depends on the domain. The application depends on the domain. If you do that, you have the guarantee the domain will know nothing about what's in the application module. And in the application module, I will keep my DTOs and my facades. So by compilation checks, you can't ever see anything from here, which is very cool, right? Now, to explain what you just saw in the code, you saw just two modules, right? Domain and application. This is what I normally do. I merge all the garbage, and I construct just two modules, domain and application. And trust me, for even large application, this worked perfectly. I led 7 projects at IBM before I left, and they were very good. I mean, one of them was 8 people, 3 years of development, 50,000 lines of code. It works perfectly with just 2 modules. We actually had a brainstorm once. If we gain anything if we break here and here, and we all agreed that we wouldn't gain anything if we broke it into more modules than these 2. So this is why I have these 2 modules here. In one module, I have my adapters and my facades, both going outside into the wild and coming from my UI, and any repository which can then select directly DTOs, like I mentioned. Right? Because yeah, if you put the repository over here, you can actually see the DTOs that we had. Right? You can select from the queries directly the DTOs, which is extremely interesting. Some people actually call this light CQRS. You can select directly the DTO that you are throwing as a JSON. Very pragmatic stuff in here. And I only have 2 modules: application, aka garbage, and the holy domain. Now, that place where you take off your shoes when you enter, this is your domain. Perfect. This is it. This is the pragmatic onion. And it worked perfectly for me. All right, what we've talked about here until here, it's only separation, horizontal separation, if I can say that. You realize that we only talked about separating these 2. Actually, look, in orange, I will color the garbage. In blue, I will highlight the holy stuff: entities and business rules, domain services. Cool stuff. But this is still a horizontal breakdown of my application. It's just a way to organize layers. Okay, in a more fancy way, with dependency inversion here, with isolating DTOs from entities by dependencies here. Okay, but they are layers. Now, let's move on into what really kills a legacy application. A legacy code base is typically killed by dependencies going between places that shouldn't depend on each other. So imagine a monolith. I mean, a big, huge ball of mud. Not all monoliths are bad, as you will see, but imagine some big code base. Imagine this package, com, my org, my app. And then at some point, oh, just before you get there, I want to show you just one thing. It's so good. Look here. Let me read you this. First of all, this is a JUnit rule, runs on Jenkins, right? JUnit test. I import all the classes in the package Victor training, and I say that no classes from domain, should depend on any class that in the package infra. What am I doing here? Nothing from the domain package must depend on the infra package. By static code analysis, this checks your classes. And if it finds a dependency from the domain into the infra, we just mentioned it. We don't want that. We want dependency inversion. Infra to depend on domain, not the other way around. So if you violate this rule, your Jenkins test fails on your unit test fails on Jenkins. Excellent. So you see, you don't really need to have different modules like I did over here. You can have a single monolithic application, a single Maven module with a rule which breaks the build if you violate the package conventions, the package rules, which is very cool. And now moving on to what I wanted to get to. I think I might be several minutes past but let's see. come my work, my app. Most applications out there have this. Right? This is how. Yeah. But then you have controllers, service, entities, and infra repository. Okay, packages. Very good. Everyone has this, right? But then after a while, after maybe 1 year, 1.5 years, you realize that there are so many entities in there. So because you have to scroll in the package to see all the entities, one guy had the idea to break the entities into sub packages like order and product. I mean, those entities that have to do with order will go in here, the other ones will go in there, and so on. All right, but then of course, as repositories come hand in hand with entities, they also should be broken down. But then after 3 more months, someone else has the idea to break the services and controllers also. Wait a second, what's happening here? What you are facing at this moment is an application which wants to break itself up. It's an application which screams for structure. So what you want to do is to grab an axe and to crack it. What I mean here is that instead of having service.order, realize order everywhere. Instead of having service order, one guy in a meeting changes this. Yeah, okay, interesting. It took me 2 seconds to do this animation. It will take you one year to do this in practice. But what you get afterwards is an architecture that reveals your domain. It reveals your domain. We will have order, you will have customer, you will have product, you will have packages which explain your world basically. As I do here: order, product, supplier, user. Subdomains. And you can actually, in a very big application, you can have teams, sub-teams working on separate packages. What do you mean? And you can actually write another rule like we've just saw, which says that slices underneath DDD, any slice, I mean order, product, supplier, user, any of these, should not depend on each other. Ha! Oh my God. Except dependencies that go towards common or infra. Actually, this should be destroyed already. So this is another static check rule. Apropos, by the way, the framework that you want to look at is Arc Unit. This is what enables me to do this. And you can actually make a unit test which proves that these packages are independent to each other, which is insane. I mean, whoa, really? Yeah. So you don't want to have dependencies between these two packages. So what do? Tricky. You don't want to be calling freely. You do have, you can't just delete the invocation between them. It's just that you want to control those. And how do you control those? By throwing events. It's one way, from one to another, or by calling from each other to one another through some DTOs, by using DTOs artificially just to call yourself. I remember you asking me to move the time frame. Can I continue still for 5 more minutes, or is it better to end now? If you can guide me on this.
Well, we can continue, but there are some questions also. So
I saw them.
We might be hurried.
Well, yeah.
They're in the question pane.
I can't see.
If you cannot see, I can copy to chat.
I can't see it. Sorry, I'm really sorry.
Yeah, you can see in the chat right now.
Now I can see.
One question is
you couldn't do on the repository level. Let me see what we're talking about then. You couldn't do on the repository level. This you couldn't do. The dependency version probably you mentioned, but I said that probably decoupling the repository implementation I just mentioned, it doesn't really pay off much. Some of the repositories will be in here in the domain because they talk in terms of your.
Yeah, it's related to GPQL parts.
GPQL. You can do on the repository level. What do you mean you can't? You can very well. Why? What do you mean you can't?
If you want, you can unmute yourself, by the way.
Yes, whoever asked this. If he, I'm not sure if he can unmute himself. There was a. If not, ask again. Were there any other questions except that?
Okay, I'll try.
Let's see the other one, and maybe in the meantime, whoever asked first one can ask again.
There is one more question.
Please.
I am again pasting to chat.
Yes. Where do you fetch database entries, facade or domain services? Well, basically both. Both facades and domain services have the ability to inject a repository and then fetch stuff from the database. So I'm perfectly fine with injecting the repository in the facade, and for some use cases, going directly to the repository from the facade. Whereas in other cases, like wherever is big complex logic, this probably should go to customer service.base logic. In that case, the customer service will inject another repository itself. I hope this answers the customer service. I hope this answers it. This class will be in the domain, basically, or service, let's call it, right? Service in here, like this. And it will be in the service package, and this method will be in there. And I can freely inject this, make this service, and then because I'm lazy, require arth constructor, and then let's inject a constructor repository, customer repository. There you go. And this is it. You can inject your stuff. So yeah, sure. Other questions? Sorry for this.
Yes, there is one more question right now. I think it's correction from the.
No, it's the same.
Sorry.
No problem.
Sorry.
I will go.
I think it's okay. Yes. Now I paste it.
Yes. Let's. This is an elaborate question. Let's see it all. You said you could create a new DTO with the GPQL with the new word. Perfect. But because the repository is a representation of the table, you could not get information from multiple tables together. Or let's do that. So let's actually go to my the application. Let's go to my customer search repo, and I wonder why can't I or can I uncomment this? There was a problem at some point. I don't remember what exactly happened, but I think it compiles now. Look, from customer C, left join. Let's see if I have a relationship from customer. Let me quickly check the customer entity. If I have a customer entity, I don't. But this would work. C dot, if customer were entity, I can left join C dot, I don't know, tags. Or I can access customer dot address, which can be a foreign key to the address table, dot street name. This works, and it will result in a join to address table if address is a different table. Or maybe better, customer dot responsible user dot username, for example. And you can freely join from here. So there is no restriction like that. No. You can fetch data from different entities freely, and then at the end compact them in such a result, such a DTO, and return that back to your user interface or your client. Right. So yeah, super powerful thing. One of the best features that is very rarely used but incredibly powerful. We'll restrict the number of joins that will happen under the hood. We'll make sure you only fetch the exact thing that we need, not anything useless, and so on. Right. Any other question or maybe clarifications on past questions?
Well, there are no questions right now.
All right.
Both on the chat and the question page.
Well, then there was one last thing, but I'm a bit afraid to approach it because it's quite complex for this time. Instead, you know what? I will point you to listen to someone, basically. This link. What I was about to tell you has many things in common with that, but with my perspective of this thing. If you can paste this further to everyone, please, the link. It's a very good talk which says that you don't really have to break the monolith into microservices by all means. No, you can live very well with a modular monolith. So in many regards, a modular code base is better than 7 microservices. You don't really need to go all the way to microservices. You can stop along the way. But again, it's been 1 hour, and I think it was enough what I did already. So to put a picture to summarize all the stuff is that thing at the end here. So we have adapters that talk to outside APIs. We have interfaces which they implement in order to shield my domain from DTOs coming from outside. Right. Anything that has to do with VSDL, file transfers, message queues should be in here. The repositories don't need to be outside, except in the case when you want to select some DTOs, like we said just now. Except this case, repositories can be present in the domain. So I have no remorse to put a repository right here, because they actually don't do anything incredibly complex. It's only stuff based on my entity model. Then the facade and anything that has to do with your clients, well, if they are user interfaces or other applications, these should be here. These DTOs, whether handwritten or generated from some YAML file, doesn't matter, are there outside of your domain and are being kept outside by the direction of the dependencies. The facade are responsible to implement simple flows, but for more complex flows, we'll delegate the work to domain services, which can delegate in turn to other domain services, and so on and so on. In order to keep those classes to, I don't know, 200, 300 lines of code per class. Super important to keep an eye on the facades not to grow too big. Okay, very, very important in this style of architecture. But this is basically allowing you to grow the code. I mean, if logic gets big, it gets extracted here. Extracted to mappers, extracted to validators, by focusing to keep the facade as compact as possible, as short as possible. Right. Plus this trick that we which we saw together by selecting DTOs from the database. Oh, I see another question. Can you elaborate on depending on different modules? How can you fetch like customers from orders? That was the part that it was complex to cover, but indeed this is what you are struggling probably with. Okay. So imagine these two, you want to keep them independent, but still from the order part, you do need to fetch some data from the customer, right? You do have to fetch some data. How would you do it? Always keep in mind what microservices would do. If these two were different applications, so first, my perspective is a post-apocalyptic one. So there were the hype of microservices, and then we are here today. How do we do stuff? Knowing the pain that we need to go through to put microservices in production, but also very aware of the pain that monoliths, millions of lines of code can do to us. So how do you do it? Well, if these were separate applications, the only contact between those should be some DTOs, right? So then one way to do it, although you might say it's a bit like scratching your head like this, is not directly calling to each other, but inventing yourself some DTOs that you call. So basically, look, my service, my order service, when it wants to get some customer data, will go through its infrastructure, go to that other module in this way, not calling from service to service, but going through infra. And my infra can call into that guy's facade, basically speaking. So you are emulating, in a way, what a REST call will do, because that's what will happen. but still without paying the price of distributed applications, deployment, Kubernetes, and all that garbage. So it's just one single code base with rules, right? It's tricky, and some people will think, oh, it's over-engineered. But the goal is not to have any dependencies between your domain between your domain services. This is the goal here. So supplier, this service should not know, basically all these domain parts should know nothing about these, nothing about these. The pain points that you will suffer is that you will have to convert data to DTOs, getting in here, convert data in DTOs again. This will be the conversion happening all the time. And there will be another thing happening which will confuse you. It will happen that in your entities, there will be here in the order part, there will be a product entity. Although there is another product entity in here, in the product part. Why are they two products? Oh my God, two tables you mean? Oh Christ, why do you mean like that, right? So imagine here customer, product. But the difference is that the product entity in here has 4 fields. The product entity in the product world has 40 fields. This is why we do this. Because there is a different representation. Oh, and of course, there is also a product DTO somewhere along the way, which is used to pass data from one to another. Quite insane, huh? Okay, should we use GPA entities as domain entities, or should we separate them, map them between? Thank you for the question.
This is the addition question from the same.
Perfect. I hope you aren't facing this. I've seen teams in great pain, by having different models, different entities model than the persistent objects. So to expand the question for everyone, typically there is some ivory tower architect somewhere who never writes code anymore, which decides that it's a bad practice to work in your domain logic with objects that are mapped using Hibernate to databases. Why do I say that probably is a decision from someone who never writes code anymore? Because the pain you have to go through if you go on this path is extreme. You have to convert from the persistent entities to your domain entities, and then from entities to DTOs. I've just worked with such a team several weeks ago. They were in great frustration because they were mapping all the time, map, and all sorts of stupid bugs because and just imagine adding a new field in the interface. So there is one more field here, one more field here, one more field here, plus one conversion to do to, one conversion from, one to, one from. You just changed what, 10 lines of code for a single field. What the heck, right? I mean, I don't know, really. So this is for 99% of teams. This is not paying off in the end, and they are just putting your teams to pain. In another perspective, this is a good idea if you're using given sourcing, or if pay attention, or if the schema that you are selecting from is not under your control. The schema, the database schema, the structure of the table is the database schema of a legacy application that you can't really change. Like imagine thousands of tables, this kind of stuff. And really, this is a very dramatic scenario. And yeah, you are in pain anyway. So yeah. But the point is not to map your mindset to the entities that are there already. But if you can change your tables, you can adjust them a bit, then there is no excuse. There is no reason to separate them. Another thing to keep in mind is that there are extremely advanced ways to use Hibernate to suit your needs. And this will be exactly the purpose of my follow-up in 12 May. Exactly the purpose of this discussion of how do I really build an expressive model using Hibernate mapping. There are some advanced features in there that few people know of that you can use to build an entity which is really very, very friendly and expressive and focused. How do you impose good OOP practices like inheritance? Inheritance is the good practice? My God, no. Or value object to GPA. Well, first of all, to answer your question, value, I mean, you can you can persist inheritance with GPA. Inheritance strategies, there are 3 strategies in there, but I've done it in most of my projects. But how to say it? You can persist. It is based on a discriminator column. You persist different types of entities in the same table. Actually, there are 3 strategies as I mentioned. Google inheritance strategy GPA, and just this one to advanced mapping. This is it, my friend Baldun. This is it. Now another question in here: how do you value object? Now that's a better question. How do you persist value objects? And this is a very interesting question, really. Let me see if I have it already. Yes, this is a value object. Why? It has no ID. It has fields. The fields are not final. Yeah, I know. But there are no setters. You do realize. Interesting. There are no setters. The only way a developer can construct this is through the constructor, which also enforces validation. Ooh la la. Right. But then also, please note this guy. This guy is let's make it actually private constructor used by Hibernate to construct to instantiate this value object when reading from the book, right? But then this product price is referenced in my product as embedded, right? Is referenced as embedded. Now this is the way to persist value objects. Actually, you get you hide the setters. You only have a constructor accessible for developers, which is taking all the parameters, and then you persist it in the same table as the product using embedded. It's a bit elaborate, but you can do it. This is what I mentioned by advanced mapping with Hibernate, right? So this is the way, basically, to persist value objects with GPA. Right? These are effectively immutable, and you have to have a price. Look, this entity also enforces constraints on the price. I have to have a price. Require not null. Good stuff. Other questions? Other questions in here? I could speak like this.
Well, there are no questions, and we run out of time.
Okay, sure. So let's end it now. Yeah. Thanks a lot for all the questions. Very good stuff. Very good points you mentioned. And what can I say? In case you want to reach me out afterwards, maybe put my contact page. But I'm on Twitter. You can Google me. You can find me. I'm on Google. So that's it. Thanks a lot for being here. Thanks for accepting this talk. And yeah, hope to see you for another one. Who knows?
Thank you, Victor, and thank you, audience, and also Balazs and Fatih. Thank you for your questions, and have a nice evening.
You too.
Bye.
Bye. Bye. Leave the webinar. Yes.